In OWASP's Top 10 2021 list, cross-site scripting, or XSS, was defined as part of injection attacks, the third most frequent and critical web application security risk. With potential impacts such as remote code execution, credential theft and malware delivery, it is important to understand how to prevent such attacks. But first, we have to understand what exactly XSS is. OWASP defines cross-site scripting as a type of injection, in which malicious scripts are injected into otherwise benign and trusted websites. XSS attacks occur when an attacker uses a web application to send malicious code, generally in the form of a browser-side script, to a different end user. To give an example, let's say a benign website is composed of HTML and JavaScript. Now, an attacker somehow manages to inject malicious JavaScript or HTML into the website, by leaving it in a comments field for example. This malicious script displays a fake login form. The next time a user visits this website page, they are presented with this fake login form, and they unknowingly send their credentials to the attacker. The script could even redirect the user back to the legitimate website, and they would have no idea that the attacker has their login credentials. By the time they realize their credentials have been stolen, the attacker would likely have already caused the damage. That was an example of stored, or persistent, cross-site scripting. The attacker sends the malicious code and it is stored somewhere on the web server like an SQL database. The next time a victim requests for that page, they are served the page along with the malicious code. This malicious code will be executed on the victim's browser, causing any intended damage. This malicious code will keep being served to anyone who requests for the page, until somebody removes it from the database. Another type of cross-site scripting is reflected XSS. Reflected XSS happens when a web application receives data with a HTTP request, and returns this data in the response without proper validation or sanitization. The data is reflected off of the web server, hence reflected XSS. Let's say a website takes your name and prints it out in a statement saying, "Hello," with your name next to it. This works because your name, the data in this case, is reflected off the web server and onto the view page on the browser. If, however, malicious code is supplied to this name data field, it can also similarly be reflected back to the view page sent to the browser. The code will be executed on the browser side, causing any intended damage. Typically, reflected XSS vulnerabilities are exploited through use of URLs. Attackers will send these URL links to victims and entice them to click on it through social engineering techniques like phishing. The malicious payload will be sent and reflected off the web server onto their own browsers. The browser runs this code because it originated from a trusted server. Comparing these two types of cross-site scripting, many consider stored cross-site scripting to be the more damaging of the two, as the attack is contained within the application itself. It does not require any actions on the victim's side to trigger the exploit, like clicking on a link. Both types of cross-site scripting can happen due to a lack of input validation and output sanitization, where whatever is sent to the server is fed back to the user as it is. In other words, input supplied by the user is not properly tested before it is allowed to enter the information system. At the same time, the application does not clean and modify output data to ensure that it is not interpreted in a way not intended by the application developer. This ultimately leads to injection attacks like cross-site scripting being possible. The last type of cross-site scripting is DOM-based XSS. DOM stands for Document Object Model, and it is a tree of objects created at runtime when a web page is loaded. Its main purpose is to act as an interface to allow programs to change the document structure, style and content. DOM-based XSS occurs when this DOM environment is altered from the victim's browser, not the HTTP response. In that sense, DOM-based XSS occurs solely on the client side. If an input is able to find its way into the DOM, like a document.write command, Attackers can supply malicious input to this DOM method. Sometimes, simple implementations of input validation and output sanitization are not enough. Attackers have found ways of bypassing these filters to allow their code to still be run. Here is an example, where the script tag is blocked, because the filter looks for the string script and blocks it. An alternative to the script tag is event handlers. There are many event handlers that come with most HTML tags, and they all allow you to run a script triggered by an event. If an image tag is set to produce an alert when an error occurs, like trying to load an image that does not exist, it will produce that alert. This is an example of how JavaScript can still be run without using the script tag. Another way that attackers might bypass simple string checks would be through the use of encoding. Replacing some or all of the characters with their URL encoded equivalents could also allow them to bypass these filters that would otherwise have caught the string. So, how can we defend against cross-site scripting? As mentioned earlier, two methods of preventing XSS are input validation and output sanitization. We should look at input validation as our first line of defense. If no malicious code is allowed to enter the system, it cannot be served out. For starters, we can check and reject certain inputs that do not match expected patterns. This is easy for inputs that have expected, definitive patterns like emails, phone numbers, dates, etc. We can use regular expressions to match these patterns and reject any input that does not match them. However, input fields where there are no strict patterns like name or description inputs could potentially leave entry points for malicious characters. In such instances, output sanitization should be used. Sanitization is the process of removing or replacing submitted data to ensure that outputted data is safe. Replacing characters such as the less than and greater than signs, ampersand, single and double quotation marks and backslash with their HTML entity equivalents can ensure that they are not interpreted as JavaScript on the front end in the browser when it is served to users. The Node.js Validator module is an external library that can be used to both validate as well as provide output sanitization for strings in your web application. It is also important to note that client-side checks are insufficient. Proxy tools like Burp Suite can intercept HTTP requests and alter them before they are sent to the server, effectively bypassing any client-side validation. As standard practice, input validation is often performed as early as possible, and output sanitization as late as possible. To recap what we have gone through, cross-site scripting happens when a web application serves users browser-side script from an untrusted source in a way that was not intended. The impacts of this are up to the attackers, as they are essentially allowed to submit any arbitrary code. There are a few main types of cross-site scripting, namely stored, reflected and DOM-based XSS. The main difference between them is that for stored XSS, the malicious payload is stored somewhere on the web application, and it is served every time the user requests for that specific thing. Reflected XSS on the other hand relies on the malicious payload being sent to the web application and reflected back onto the victim's browser, often through the use of a URL. Finally, DOM-based XSS happens when input is allowed to contaminate the DOM, causing malicious JavaScript to be run. Finally, to prevent against cross-site scripting, input validation and output sanitization should be used. When implemented correctly, they can help to filter malicious input from entering the web application, and also prevent these payloads from being interpreted as malicious code on the browser side.